So now let's look at the plus 6 oxidation state. So in the plus 6 oxidation state, we are going to see two forms in which chromium exists. That is, we have what we have just looked at, that's the dichromate. Dichromate is written this way. You have your Cr2. I don't know why it's not working out well. You have your Cr2, and then you have your O7 2 minus. That's our dichromate. So dichromate is written like that. And then we have another one, which is the chromate 6 ions. So all elements in the plus 6 oxidation state will be in this form. So we have the dichromate, and then we have the chromate ions. So dichromate, so I'll clear this a bit. We have the dichromate, and then we have the chromate 6. So if you use chromate, you add the 6. If you use dichromate, just you don't add anything like 6 or what. So this one will be chromate 6 ions or dichromate ions. That's how they will be called. Don't say dichromate 6, it will make sense. So having known that there are two forms, we can now look at two or three more things about these two. We shall start with the color. So this one will appear orange in solution, as you are going to see some of the compounds. So this one will appear orange, and then this will appear yellow in solution. So the chromate 6 will appear yellow in solution. Yellow in solution. So those will appear yellow in solution. And then the other thing is about their stability. These will be very much examined. So if you don't understand the stability now, just know you'll be in danger. So take note that the dichromate will be stable in acidic conditions. In acidic conditions. Then this one, the chromate, will be stable in basic conditions or alkaline. Let's use alkaline. In alkaline conditions. So what do I mean by acidic? It's when we have hydrogen ions present in solution. And what do I mean by alkaline? It's when you have hydroxide ions present in solution. So you can also take a note of that. So here, to be stable in presence of hydrogen ions. So this will be stable in presence of hydrogen ions. And this will be stable in presence of hydroxide ions. And now, so after knowing the pH, we shall see how this pH actually helps in the oxidation ability. We shall see that these two are actually very strong oxidizing agents depending on the pH available. That's the dichromate will oxidize in acidic medium. From that, we need to look at two things, which is called base base acid equilibrium equation. So having seen that this is stable in acidic and chromate is stable in the alkaline, it means if we added an acidic medium to a solution containing chromate ions, they will rather change to the form which is stable in acidic medium. That is, the chromate would change to dichromate. You get? If we added an alkaline solution to a solution containing dichromate, they would also change to the form which is stable in alkaline medium, that is the chromate. You get? So we shall have that interconversion. So we are going to have the half reactions for each. That is this in acidic medium, and we also look at the dichromate in alkaline medium. So starting with the dichromate, shall have our Cr2O7 2 minus, that is dichromate, and then the state, this is aqueous. So we are seeing that we are adding something in which it's not stable, which is the alkaline. And the alkaline medium will be provided by hydroxide ions, which can be from maybe sodium hydroxide solution. So we have hydroxide ions. Also, this is aqueous. And we are saying this one, after adding the alkaline medium, it will change to a stable form. Which form is stable in alkaline medium? It's the chromate. So this will change to the chromate. So we shall have chromate being formed in alkaline medium. So this is 4 2 minus, and this is aqueous. And then what else do we expect from? We expect from water. To change to the stable form, which is dichromate. So one may ask, why is it that we haven't formed hydrogen ions this side? It's simply because if we formed hydrogen ions, it would mean this would be a reversible equation. But remember, we are still writing half equation. You get? So it means that we are having just the chromate and water in which it will be stable. So let's balance this. We shall have a 2 here for chromium. And then what are we balancing next? Oxygen. Oxygen, this side we have 8, and what of this side we have a total of 9. You get? So how are we balancing this? Let's add here a 2, which automatically balances the number of hydrogen atoms. What of the charge? The charge, we have total of negative for this side and a total of negative for that side. So that equation is well balanced. What of the chromate in acidic medium? So that we are saying that if we have a chromate and we add hydrogen ions, it will change to a form which is more stable. So if we added hydrogen ions, get if we added hydrogen ions, this will change to a stable form which is stable in acidic medium, which is the dichromate. So we would have dichromate being formed. So we have dichromate being formed. So we have that aqueous. What else do we expect from? We expect from water. We expect from water. So we have our water formed as well. Shall we balance this equation? Yes, we can. So I can erase this. It's too big. And that correct it. So we have water. So let's balance this equation now. We have chromium to this side and we have 1. So we can start by balancing this side with a 2. If we put here 2, it will directly be affecting the total number of oxygen atoms this side to 8. And what of the right hand side? They are also 8, which is well balanced. What of the hydrogen atoms? Hydrogen atoms, this side 1, this side 2, so we need a 2 as well here. And finally, we look at the charge. So we have a total of -4 here plus 2, which changes to -2. And what of the right hand side? Also minus 2. So these are the half reactions for the base acid equilibrium reaction, which we are going to write now. So you can see that when I add alkaline to the dichromate, it will change to the form which is stable in alkaline medium, that is the chromate. If I added acid to the chromate, to change to the form which is stable in acidic, which is the dichromate. So you must have a good understanding of these reactions, which will be very important in the practicals. For example, you can have a solution containing chromate ions. They tell you to add an acidic solution with a target of forming dichromate ions. You get? So they can tell you that to the resultant solution, which will be what? This is orange, yellow. You get? So you have a yellow solution turning orange on addition of hydrogen ions from the acidic solution. So they can tell you that to the resultant solution, add it to this to do maybe the oxidation. You get? Can tell you add it to a solution containing iron to ions. You get? And you have the iron to ions maybe changing to iron 3, as we are going to see part of the practical. So let's now write the overall equation for the base acid equilibrium. So for the base acid equilibrium, we shall have one of the equations reversed. Get? Let's see. Yes, we shall have one of the reaction of the equation reversed. Let's say we are reversing this one here. We shall have something like this. Shall have chromate this side, have chromate. Shall start with chromate, and then we have there two. We have this water, have water, which is a liquid, and this was actually coming from the reaction of dichromate with alkaline medium. So we have the dichromate, was coming from dichromate reacting with alkaline medium. So take note of the arrow where I've actually pointed it. It's intentional. So you can see that this reaction is now coming this side, but it's what? It's reversed. So let's have an overall equation where we can just add these two. Get? So let's have these added. So if you add these two reactions, you can see that this and that can actually cancel out. You get? Let me use a different colors for our clear view of it. So water on the left will go with water on the right. What of the rest? Do we have to change anything here? Not really. So we can have these two equations added together. So we can have this will be 4 chromate 4 chromate. This is aqueous. And then we have 2 hydrogen ions. So what will be the nature of the arrow? It will be a reversible arrow because one is facing in the right direction while the other one was facing in the left direction. So we shall have this type of arrow, reversible. So we have one facing that side, we have another one facing to the left. So this side we have 2 of these, the dichromates, 2 of the dichromates, and this is aqueous, 2 dichromates, 2 dichromates, and our 2 hydroxide ions. So from the view of things, you can see that we can actually divide it out by a 2. So someone can just divide it out by a 2, and this will change to a 2, 1, 1, 1. Okay, I'll correct that. So this will be a 2, and then this was our hydroxide. So I'll just put back the oxygen. You get? So that's the balanced equation. Here we had C. Okay, so what we have now is what we call a base acid equilibrium equation for chromium 6 ions. You get? So why it's called a base acid equilibrium equation and not a redox reaction, because we are actually remaining in the same oxidation state, that is the +6 and also +6. It's just dependent on where on the pH. If it's acidic, we shall have dichromate being formed. If it's alkaline and we have this, we shall have chromate 6 being formed. You get? So that's the base acid equilibrium equation I was talking about.